Have a good day. Let me introduce our presentation. Our presentation is named Design and Research of Biological Active Polymeric Hydrogel Transdermal Materials Modification by Humic Acid. The modern trend in the area of biological active polymers and materials based on them is the technology that allows to create effective system for drugs and active substances transdermal delivery into the human body. Use of biological active preparation hydrogel can be based on numerous biopolymers such as collagen, gelatin, arginate, chitosan, and many different others. So the aim of our research is to design and research of biological active polymeric hydrogel transdermal materials modification by humic acid. In our studies, objects for biological active polymeric transdermal hydrogel designing were food gelatin, brand 11C grain, sodium alginate produced by China, humic acid we received by extraction from lignite. We used several methods for research our biological active polymeric hydrogel. We used conductometric studies by a combined TDS meter. So we use microscope studies for biological active polymeric hydrogel using electron microscope, digital microscope, HD color MOS sensor produced in China. For determination of moisture-lipid skin balance, a professional skin moisture and oilness analyzer SK92 produced by China were used. The moisture-lipid balance will be measured into the area around the eyes before and after applying biological active polymeric hydrogel transdermal materials for 15 minutes in 20-30 years old women. The skin moisture and oilness range is from 1 to 99.9%. In the first stage, the biological active polymeric hydrogel transdermal materials based on gelatin and sodium alginate, conditional viscosity and conductivity dependence from the different humic acid content the results is shown in the slide 5. Next study we carried out to determine the effect of modification of humic acid in the most important operation properties, which is shown in slide 5, of biological active polymeric hydrogel transdermal materials, swelling degree, and effect of moisture-lipid balance measured of skin. So, as we can see from the slide 5, the operation, the most characteristic changes that increase in biological active polymeric hydrogel transdermal materials conductivity, viscosity, and specific electrical conductivity, with an increase of humic acid content. Such changes indicate the following feature of the humic acid modification of the process of structure formation in biological active polymeric hydrogel transdermal materials based on gelatin and sodium alginate. More density and rigid network of biological active polymeric hydrogel were structured. Also, the formation of a large number of agglomeration in the hydrogel shows that the modification of the gelatin-based biopolymer hydrogel by humic acid make it possible to obtain hydrogel transdermal material with increase in swelling degree. The formation of a large number of agglomerates in biological active polymeric hydrogel and transdermal materials in different content of humic acid is clearly visible from the microscope studies. Results shows in slide 6. Most important that the note that the using the new biological active polymeric hydrogel transdermal material modified by humic acid allows to improve the skin moisture lipid balance from initial values of 34-36% moisture and 8-10% skin fat. They increase to level for 38-66% and 42-16% respectively for moisture and skin fat. As it can be seen from the slide 5, we can show the improvement in the moisture-lipid balance of the skin increase with the increasing in the content of humic substances. So actual modification by humic acid make it possible to obtain hydrogel transdermal materials, which when applied to the human body will allow to regulate the moisture-lipid balance of the skin uniformly and for a long time. In fact, like it shows from slide 6, the biological active polymeric hydrogel transdermal materials based on gelatin and sodium arginine modified by humic acid using becomes possible to transfer the skin from slightly moisture fatty hard to highly moisture fatty elastic condition. The moisture lipid balance skin improving increase with increasing of humic substance constant. So we can make such conclusion of our research. The effective biological active polymeric hydrogel transdermal materials based on gelatin and sodium arginate modified by different humic acid content were received. Modification of humic acid make it possible to obtain polymeric hydrogel transdermal material with increasing swelling degree and ability to improve the skin moisture lipid balance. In future, research is perspective to determine transdermal level of design biological active polymer hydrogel for most important medicine and cosmetic biologically active substances. So thanks for possibility to make my presentation. I am ready to answer for all questions.